we have seen lateral shift. Now we are going to see how lateral shift varies with angle of incidence. Variation in lateral shift with angle of incidence I. As you know, it is a glass slab of thickness T. If you incident light on it at some angle theta, this is angle of incidence. This is the original path, but as it is entering into denser medium, so it will deviate from its original path. And then it comes out like this. So this angle is angle of refraction. So this angle will also be equal to angle of refraction. This was lateral shift. Let it be delta x. So lateral shift is this delta x, and this angle is I minus r, because this whole angle is angle of incidence and this is angle of refraction. So I minus r is angle of deviation. This is angle of deviation, and delta x is the lateral shift, means how much light has shifted perpendicular to direction of propagation. This is called lateral shift, and we have derived formula for lateral shift as delta x is equal to T upon cos r into sine I minus r. This we already know. Now as angle of incidence increases, I increases, R also increases. What can be maximum angle of incidence? That is 90 degree grazing incidence. So when I approaches 90 degree, that is grazing incidence, R approaches critical angle. So delta x maximum is T divided by cos r. Now r is critical angle into sine I is 90, r is critical angle. So this is my maximum and lateral shift, and this will be T thickness of glass slab divided by cos C into sin 90 minus theta is cos theta. So here I can write this as cos C. Sin 90 minus theta is cos theta. So this cos C is cancelled. So maximum value of lateral shift is equal to thickness of glass slab. So remember this result. This is maximum thickness lateral shift possible, and that is equal to thickness of glass slab. So if you draw a graph between angle of incidence and lateral shift, graph between angle of incidence and lateral shift. How it looks like. Suppose this is angle of incidence and this is lateral shift. As you know, maximum value of lateral shift is thickness of glass slab. Lateral shift doesn't exceed this value. So this is maximum lateral shift. And if you do a graph between I and delta x, it appears like this. Here it is 90 degree angle of incidence, grazing angle of incidence, and here lateral shift is maximum, that is T. So that is how lateral shift varies with angle of incidence. Now one numerical on lateral shift. Numerical on lateral shift, just to make you know how to use the formula derived. Suppose this is a glass slab whose thickness is 6√3 centimeter and its refractive index is suppose √3. A light is incident on it at suppose 60 degree. You have to find what is lateral shift produce. So light will follow path like this. This is the lateral shift delta x that we have to find. So now we know formula delta x is T divided by cos r into sin I minus r. This we have to use. So here if I use Snell's law at this point in order to find angle of refraction. So it is air 1 into sin 60 is equal to √3 into sin r. So it is √3 by 2 is equal to √3 into sin r. From here sin r is 1 by 2 because √3 get cancelled. So r is 30 degree. This we know. So lateral shift T divided by cos r, cos 30 degree into sin 60 degree minus 30 degree. So it is T divided by cos r. Cos 30 degree is √3 by 2 into sin 30 degree, it is 1 by 2. So T 2 cancel. So it is T, that is 6√3 divided by √3. So it is 6 centimeter. So this is lateral shift. Whether it is maximum, answer is no. Maximum lateral shift is same as thickness of glass slab. and that occurs when angle of incidence becomes 90 degree. So it is not maximum. What is minimum lateral shift? It is 0. When light is incident normally, there is no lateral shift. So minimum value of lateral shift is 0. Maximum value of lateral shift is thickness of glass slab. So that is how you are going to apply the formula. Here I am going to define critical angle. Critical angle. So before defining it, let's see suppose this is denser medium, a rarer medium, a refractive index is mu d, refractive index is mu r, refractive index of rarer medium, refractive index of denser medium, and this is interface separating the two media. If I incident a light here along normal, here light is incident along normal, so it will go without any deviation from its path. So one angle of incidence is 0 degree, angle of refraction is also 0 degree. So here there is no deviation. Now if I increase angle of incidence from 0 to I1, angle of refraction also increases from 0 to R1. But see here, increment in angle of incidence is lesser than increment in angle of refraction. So here I increase I a small value, but here I am getting more angle of refraction. If I further increase I further increase I found further increase in angle of refraction. So here angle of incidence is increased, angle of refraction is also increased. When I further increase angle of incidence, angle of refraction becomes 90 degree. This is a particular case, a specific case for this given pair of media. Now the angle of incidence at which angle of refraction becomes 90 degree, this angle of incidence is called critical angle. But it is not necessary that light must go from denser to rarer medium in order to define critical angle. If light is incident at 90 degree in rarer medium, then it is refracted at angle C in denser medium. So if angle in rarer medium is 90 degree, then angle in denser medium is called critical angle. Maybe angle of refraction or angle of incidence. So when light goes from denser to rarer, I say angle of incidence at which angle of refraction becomes 90 degree. When light goes from rarer to denser, I say angle of incidence or grazing incidence. So if angle of incidence is 90 degree, angle of refraction is equal to critical angle. It means when light goes from rarer to denser and angle in rarer medium is 90 degree, then angle in denser medium is critical angle. Means whenever angle in rarer medium is 90 degree, whether it is angle of incidence or angle of refraction, angle in denser medium, whether it is angle of incidence or angle of refraction, is called critical angle. So when angle in rarer medium is 90 degree, maybe angle of incidence or angle of refraction. Is 90 degree angle in denser medium. Maybe angle of refraction or angle of incidence. Then angle in denser medium is called critical angle. And that is denoted by C. So here when I say angle, I mean angle between normal and ray, light ray. So angle in rarer medium means angle between normal and light ray in rarer medium. When I say angle in denser medium, I mean angle between normal and light ray. So if suppose this is denser medium and this is rarer medium, light is going from denser to rarer, then this angle is angle of incidence and that is called critical angle, and this angle is angle of refraction and that is 90 degree. This can be also shown like this. This is rarer medium, this is denser medium, this is incident ray. So here angle of incidence is 90 degree, this is refracted ray, this is angle of refraction, and this is critical angle, equal to critical angle. So one thing clear here, critical angle is always formed in denser medium. So one thing is clear, critical angle is always formed in denser medium. Second thing, critical angle is formed in denser medium, but it is not true that critical angle will be formed only if light goes from denser to rarer medium. When light goes from denser to rarer medium, critical angle is said to be angle of incidence. When light goes from rarer to denser medium, angle of refraction is said to be critical angle. So in order to form critical angle, light must go from denser medium to rarer medium. If someone says a statement like this, do you think it is always correct? Answer is no, because light may go from denser to rarer or from rarer to denser. But yes, it is always correct that critical angle is formed in denser medium. It never formed in rarer medium. So be clear. Now relation between critical angle and refractive index of the two given media. One medium is this, other medium is this, critical angle is this. So relation between critical angle and the pair of media. If I use this figure and apply Snell's law here, so what we have to write? Mu d into sine I is equal to mu r into sine r. So mu d into sine I is equal to C. So sine C mu R into sine 90 degree. So mu D sine C is equal to mu R because sine 90 is 1. So from here we can say sine C is mu R over mu D. So this is important relation you should remember. Sine of critical angle is always equal to a ratio of refractive index of rarer medium to that of denser medium. So these two media has one critical angle. So critical angle is characteristics of the two media. If any one of the two media is changed, critical angle will be changed. So critical angle is characteristics of given pair of media. Critical angle is a constant for a given pair of media. Means if you change any one of the two media, critical angle will change. Otherwise it is a constant. So for water and air, critical angle is constant. For air and glass, critical angle is constant. For glass and water, critical angle is constant. So critical angle is a constant for a given pair of media. If you take, suppose it is water, this is air. So light may go from air to water or from water to air. Critical angle will form in water because water is denser with respect to air. So let this is critical angle. Angle of refraction will be 90 degree. So this pair of media has a specific critical angle. Similarly, suppose this is glass and this is air. And light is going from glass to air. So this is critical angle. Glass is denser than air. This is angle of refraction. So for this given pair of media, critical angle is a constant. Similarly, suppose this is glass and this is water, and light is going from glass to water. So glass is denser with respect to water. Critical angle will be formed in glass. So that is angle of refraction 90 degree in water. Now we know refractive index of water 4/3, refractive index of glass 3/2. Now here, if we use Snell's law or directly apply the result, sine of critical angle is refractive index of rarer medium, that is refractive index of air 1 upon refractive index of water 4/3. So 3 will go up. So more is ratio of critical angle is refractive index of rarer medium upon refractive index of denser medium. More is the ratio. More is the C. So if this ratio is more, you're going to get more critical angle. Now here if I take sine C, so it is refractive index of air, that is 1 upon refractive index of glass 3/2. So 2 will go up. Here sine C refractive index of water, that is 4 by 3, refractive index of glass, that is 3 by 2, so it is 8 by 9. Now see the ratio of these two. This is 0.75, this is 0.67, and this is 0.79, you can say. So this ratio is least. This ratio is least. So it has got least value. This is approximately, here see, if you write, then you have to write sine inverse 2 by 3. So this is approximately 42 degree. This ratio is 0.75. So if you find C, it is sine inverse 3 by 4, and this is approximately 49 degree. So remember these results. And this is 0.79. So C will be sine inverse 8 over 9, or C is approximately 63 degree. So remember these results. More is ratio of this, more is C. Lesser is ratio of this, lesser value of C. So ratio this, this and this. This is least. That's why C is least among all these three. So glass air interface, critical angle is approximately this. Water air interface, critical angle is approximately this. Glass water interface, critical angle is approximately this. It means if light is going from glass to water, it will go from this medium to this medium if angle of incidence is lesser than 63 degree. If light is going from glass to water, it will go from glass to water if angle of incidence is lesser than 63 degree. If angle of incidence greater than 63 degree, then this light will come back in the glass, and that phenomena is called total internal reflection. I will take it later on. Here too, if light is going from glass to air, it will go from glass to air if angle of incidence is lesser than 42 degree. Similarly, if light is going from water to air, it will go from water to air if angle of incidence is less than 49 degree. If angle of incidence is greater than 49 degree, it will come back in the water, and that is total internal reflection. Similarly, refractive index of diamond is around 2.4 or 2.5 for diamond air. Refractive index of diamond is around 2.4 or 2.5. So sin C is 1 divided by 2.4. So C is nearly 24 degree. So if angle of incidence is lesser than 24 degree, then light will go from diamond to air. If angle of incidence is lesser than 24 degree, then light will go from diamond to air. Otherwise, it will come back to the diamond. And generally, in diamond, this angle of incidence is more than 24 degree. That's why light get internally reflected, and that becomes the cause of glittering of diamond. So remember these values of critical angle. Angle of deviation. Now here, angle of deviation, we are going to read in two heading. First, when angle of incidence is lesser than critical angle, it means, suppose this is denser medium and this is rarer medium, and angle of incidence is lesser than critical angle. It means light will go in rarer medium. This is angle of refraction. So here, as you know, light is going from denser to rarer. So R will be greater than I. So angle of deviation in this case is R minus I. And by using Snell's law, we can find a relation between these two. By Snell's law, mu d into sine I is equal to mu r into sine r. Sine r is mu d upon mu r into sine I. So r is sine inverse this. And suppose angle of incidence is I. So now deviation will be I minus sine inverse this. So this is formula of angle of deviation. Now if I draw graph between angle of deviation and angle of incidence, then it looks like this. This is angle of incidence and this is angle of deviation. This graph look like this. Now, if angle of incidence is C, then this becomes 90 degree. So when I approaches C, R approaches 90 degree. Then deviation approaches from here. If it is 90 and this is critical angle, so 90 minus C. So when I approaches C, deviation approaches this value 90 minus C. And when I is slightly greater than critical angle, then this light will come back in the same medium. So second case, when I is greater than C, this is a rarer medium, this is denser medium, this is greater than C. It means light will not go in second medium, it will be reflected internally. So this angle will also equal to I or C. Sorry, it is equal to I because I is greater than C. So deviation is this much. So in this case deviation is 180 minus 2I, or it is also pi minus 2I. So if I increase very little from C, deviation reaches to this, and then deviation decreases with angle of incidence. So when I is slightly increased, deviation suddenly becomes 180 minus 2i, and then it decreases with angle of incidence, and here angle of incidence is 90 degree, because angle of incidence can't exceed 90 degree. So that is how when angle of incidence become 90 degree, it goes like this, so there will not be any deviation, so deviation becomes 0. So that is how angle of deviation changes with angle of incidence. So remember this graph, shape of the graph: diameter of field of view of a fish, you can say. Suppose this is a clear water, this is clear water, and there is a fish here. If fish want to see in this region what is the radius above which things in air visible to this fish, that we are going to find. So if I draw a normal here, so if fish try to see along this line, here things present here will be visible to this fish. Or imagine it is a bulb. So if light starts from here, it will go undeviated, and it may be able to come out from water into air. But this is not the only ray that will start from the bulb. Ray will go in all direction from this bulb. So if I select one ray that is reaching here, this is normal at this place, so angle of incidence is not 0 here. Here angle of incidence is 0. So as we go away from this point, angle of incidence increases, because here angle of incidence is 0, here angle of incidence is not 0, it is more than 0. Here angle of incidence will be more than this place, here angle of incidence will be more than this place. So as we go away from this point, angle of incidence keep on increasing. Suppose I take that ray which is falling at this place, and this angle is just become equal to critical angle. So any ray that is falling beyond this point will be having more angle of incidence than critical angle, and any ray that is incident here has lesser angle of incidence than critical angle. So if angle of incidence is lesser than critical angle, light will come out of the water. If angle of incidence is more than critical angle, light will not come out. So any light that is incident beyond this point will be internally reflected, means will not come out of water. Similarly on this side also. So suppose I take this point, ray incident here, this angle is critical angle. So any ray that is incident beyond this point will be internally reflected, will not come out of water. Any ray that is incident here will come out of water. So if it is bulb, then light will come out in this region. So there will be a circular region from where light will come out of water. And if it is a fish, This is the circular region above which fish can see. So this is diameter of field of view. This is diameter of field of view. This, and this is radius of field of view. So if I take this point as B, B stands for bulb, this point as A, this point as C, this point as D, and this angle critical angle, this angle critical angle. So light will come from water in region between D and C. So a circular region between D and C, you can say. If you draw a circle taking A as center and radius equal to AC on the surface of water, from that circular region light will come out if it is a bulb. So this is called field of view, and radius of field of view is this. So I am marking AC as R. Similarly, DA is also equal to R. So this is radius of field of view. Now if this angle is C, this angle will also be equal to C, because these two lines parallel and it is transversal alternate interior angle. Similarly, this angle is also C. So in right angle triangle ABC, this is C point and this is critical angle small c. So in right angle triangle ABC, in triangle ABC, if I write tan C, then it is AC upon AB. AB is a real depth of bulb from surface of water. So let this be H, or depth of fish from surface of water. RAC is radius of field of view. So we can write tan C as R upon H. Now we already know that sin C is mu R upon mu D. Here mu R is 1 air, mu D is refractive index of water. So cos C is under root 1 minus sin squared C. Sin square theta plus cos square theta is equal to 1. From where this comes? Now 1 minus sin C is this. So at place of sin square C we can write 1 square over mu square. So it is 1 square over mu water square. So this is cos C. You may write it like this also. Mu water square minus 1 divided by mu water square, or mu water square minus 1 upon mu water. So this is cos C. Now if I divide sin C by cos C, I am going to get tan C. So from here sin C over cos C is equal to 1 over mu of water divided by under root mu of water square minus 1 upon mu of water. This get cancelled. So tan C is 1 upon mu of water square minus 1 square root. This is tan C, and tan C is this R by H also. So equating these two tan C. So from equation 1 and 2, I can write 1 upon under root mu water square minus 1 is radius of field of view upon height of bulb from surface. So radius will be equal to H divided by mu of water square minus 1. This is radius, so diameter twice of this, so diameter of field of view 2 times h divided by mu water square minus 1. So there will be a circular region, consider like this. So what is area of field of view? Area of field of view, area of circle, that is pi r square. So area of field of view is pi r square, that is pi h square divided by mu water square minus 1. So that is area of field of view. If suppose someone asks you there is a bulb here, so light will be coming out from water in this region, and if you want to prevent light coming from here, you have to put a disc of opaque material whose radius is equal to r, such that center of disc lies above the bulb. So that disc will block all light coming from water. So these things can be asked.